Right, dear friends, so we are back once again, but this time we'll talk with respect to the limitations of Laurie-Bronsted acid-base theory. In the previous two episodes of Laurie-Bronsted, we had taken the different aspects, but in this episode we'll take the limitations of Laurie-Bronsted theory. Every theory somehow or the other has got some limitation. Let's talk about Laurie-Bronsted limitation. Now see, if you consider the compound NH3, it's a base we know very well. Fine, now we know very well, and as far as the previous episodes concerned, and it was, if you can recall, it was the limitation for the Arrhenius theory of acid and bases because it had no tendency to lose OH minus. So that was Arrhenius limitation, which was overcome by the concept of Laurie and Bronsted. We know very well that ammonia NH3 is a base now according to Laurie-Bronsted theory. Now I am going to take one more compound, and that is what I am going to write for you is boron fluoride, or you can say BF3 boron trifluoride, BF3. Now can you recognize what BF3 is? Is it an acid or a base? Now see, just if you concentrate on the compound and think for a while, you'll be confused a bit, because if you keep in mind the Arrhenius theory, then it was a theory with respect to the losing of proton and gaining of losing of hydroxide ion. If it was losing proton, it was acid. If it was losing OH minus, it was a base. Here there is no H, no OH. So Arrhenius theory will not be able to decide whether it is an acid or a base. If you consider the Laurie-Bronsted acid-base theory, there again we had a concept of proton transfer or exchange. A compound which loses a proton is an acid, which accepts a proton is a base. Here again there is no question of losing a proton because it doesn't have a proton. So according to this theory, it cannot be an acid. According to Laurie-Bronsted theory, a compound if loses a proton is an acid. Do we have H? No, we don't. So it is not an acid according to this theory, right? Is it okay? Fine. So one question it may arise to you, possibility, not a question, possibility that then sir, can it gain a proton? And if it gains, then it should be a base. Now you think over whether it can gain a proton or not. See, it is boron. Boron has got atomic number 5. It has got 3 valence electrons, and all those 3 electrons are bonded to F, that is fluorine atom, forming the molecule BF3. So there is no question of free or valence electrons on boron, and so again there doesn't arise a possibility of even gaining a proton. So you are confused as far as the knowledge of two theories concerned, Arrhenius and Laurie-Bronsted, and according to these two theories, you cannot determine BF3 either in an acid or in a base form. So now what? So that is the limitation of Laurie-Bronsted theory. That what is BF3? Now see. Actually speaking, BF3 is an acid. Yes, it's an acid. You are astonished to hear that BF3 is an acid? Yes, it is an acid. And that was the conclusion given by the scientist G.N. Lewis with respect to the same acid-base concept, and that theory overcomes the limitation of Laurie-Bronsted acid-base theory. So here I would say that limitation of Laurie-Bronsted theory is this compound, and of course many more, but we are taking everything in brief, that BF3 is, according to Laurie-Bronsted, is neither determined as an acid nor it is determined as a base. But obviously there has to be some characteristic of BF3, and I said that BF3 is definitely going to act as an acid, but that we will talk with respect to the concept of Lewis theory. That will be followed in the next episode, but I am just taking care of the limitation of Laurie-Bronsted, and due to the limitation, a new theory has come into existence. So that is all about Laurie-Bronsted theory with respect to the principle and its application and limitations, everything in the 3 episodes. You can go through every episode and prepare well till then, and we will see you in the next episode with respect to the Lewis acid-base theory. Till then, goodbye. Do take care of yourself, and you can have your queries solved on my email ID, that is stylin1411@gmail.com. Till then, goodbye. Take care.